Yeah. So this is your backpropagation algorithm. So since we are familiar now with what are neurons, how your input unit supplies the input to the output unit like that. So here for every training sample, what I have to do is, so especially in backpropagation algorithm, I have to propagate forward as well and then I have to propagate back. There are two things will come into the picture. When I consider forward propagation, when you look into this, you can come to know that. So I have to calculate the output when I propagate forward. When I move from input to the out towards output unit, I have to propagate forward. During that, what I have to do is I have to compute the output of every unit. So during the forward propagation, I have to calculate output. So during the backward propagation, why I have to backward it and then again forward, feed forward network is in order to update my weights. Probably I may not achieve my accuracy better. So again I back propagate. During the back propagation, I will learn the errors which are happening in the output unit as well in the hidden layer unit. So here you need to calculate the errors at hidden layer as well the errors at the output layer. So these errors will help you to update your weights in backpropagation algorithm. So what I'm trying to tell you here is when I'm propagating forward, I have to calculate the output. If my net output is not satisfiable, I have to back propagate. During the back propagation, what I have to do is I have to calculate the errors at the hidden layer as well. I have to calculate the errors at the output layer, right? So there are formulas. After I calculate the errors at hidden and output layer, it will be helpful for me to update the weights. So during the forward propagation, I am calculating only the outputs. During the back propagation, I have to propagate the errors backward through the network. So here, del k is the, when I am propagating back, my journey starts from the output unit, right? Then hidden layer, then input. When I am propagating forward, my journey starts from the input layer. Through hidden layer, I will reach the output layer, right? And at every unit, I need to calculate the output. I have to calculate the outputs at the hidden layer as well. I have to calculate the outputs at the output layer. When I'm propagating backward, my journey starts from the output layer. The error which you calculate at the output layer is called as del k. The error which you calculate at your hidden layer is called del h. Based on that, the weight vectors are going to be updated. The entire weight vectors are going to be again assigned to feed forward to calculate the output. Any doubts till now? Yes?
No, ma'am.
Yes. Yes. Let me go to the next frame. Just look at this. This is the problem which I have taken to you. So here, how many neurons are there in input layer is 3 neurons, right? I have 3 units in the input layer. I have 2 units in my hidden layer, 2 units in my hidden layer, and I have 1 unit at the output layer. So I have only one hidden layer. So I have only one hidden layer. You can look at that. And how do I calculate output is your bias weight plus the multiplication combination. We have seen in the last class, it is of summation of x and then w's, right? Summation of x and then w's, input and then weights. When I am calculating output at 4, since these are all your input vectors, right? 1, 2, 3 is your input nodes, 4, 5 are the hidden layer nodes, 6 is the output layer node, right? When I'm calculating output at my hidden layer called 4, which are the two things I have to consider is weights and then inputs. So It is of x1 is the input, x2 also going to 4, x3 also going to 4. So what is the combination you will try here is x1 into W14 weight from 1 to 4. The weight is W14. Then x2 into W24, right? Then x3 into W34 plus bias weight of 4. What is the bias weight of 4 is W, probably it is 0, 4. W04 plus all these combinations, whatever I have told you, x1 into W14 plus x2 into W24 plus x3 into W34. So along with the input, you associate the weight by multiplying it and then send it to the output node. And the summation of all these input vectors and the weight vectors multiplication is nothing but the output. Along with output, you always add the bias weight of a particular node to calculate the output over there. Fine. Likewise, how do you calculate output at 5 is, it's all of x1 into W15 because weight from 1 to 5 is W15. Then x2 into W25. Then x3 into W35. Then this is, what is the output? How do you calculate output at output layer? Since I am feed forwarding, I didn't come back. When I'm coming back, I have to calculate the errors at 6. I have to calculate errors at 4 and 5 because I have to calculate errors at output layer and then the hidden layer. By learning the errors at output and then hidden layer, I can able to predict the new weights. I can update the new weights and then again I'll go forward. Right? So now, which and all the things will act as inputs to 6? The output, whatever you have calculated at 4, will act as the input for 6. So the output value of here multiplied with W46 plus bias weight of 6. And whatever the output you have calculated at 5, this will act as input. That value multiplied with W56 and then the bias weight at 6, that is W06, will be the output of 6. Any doubts till now? It's just a basic explanation. I'll just go with the values later. Yes. So what are the input values I am supplying? I have taken the x vector. You can see that x vector. The values are 1, 0, and then 1. Right? The values of x vector is 1, 0, 1. What does it mean? x1 value is 1, x2 value is 0, x3 value is 1. Right? I told you eta is the learning rate. At what speed your network is learning. I have taken the learning rate value as 0.9 and whose class label is 1. So actually class label 1 is your target concept, no? So your target output T is equal to 1. All these are required. I'll explain you the algorithm while I am solving the problem. Okay? I mean, one layer I have done. Only thing is how to apply the values based on the formulas. Fine? Now, so the output, whatever you're calculating, that is not your actual output. Always you have to apply the sigmoid function. What is sigmoid function? If you calculate output at x1, that x1 has to be applied to which formula? 1 by 1 plus e power minus your output, whatever you have calculated at x1, then x2, then x3. For example, sorry, here you are not calculating outputs, but at 4 and 5 you are calculating, so that this is not the exact value after multiplying your inputs and weights. Exact value is based on applying the sigmoid function on the value you are got, net output. So we are applying our net output towards activation function. This is the activation function which will make you to 1 or minus 1. Right? Yeah. Please look at, these are the values I am supplying. So what and all I have seen in the pictorial representation, the previous frame, x1, x2, x3, you know that those values are 1, 0, 1. I have a weight which is supplying from the network from the neuron 1 to 4 and then 1 to 5. 4 and 5 are hidden layer units, right? So 1 to 4, 1 to 5, like that, from input 2 to 4, 2 to 5, and then from input 3 to 4, and then from input 3 to 5. So these are all the weights I am supplying from one node to the other node, from the input network to the hidden layer, right? So, and then you have an output called 6, output node called 6. The weight I am supplying from the hidden node 4 to the output node 6 is W46. Like that, I have one more hidden node called 5. So 5 to 6. And these are the bias, because where and all you are calculating outputs, I am calculating outputs at 4 and 5. So these two are the hidden layer nodes, and then I'm calculating output at 6. So which and all the nodes you're calculating outputs, obviously it will have a bias, which will have the bias weights W04, W05, and then W06. Fine. Now you have to calculate the net output, right? Net output, where and all I'm calculating. Just look at. So I have to calculate output at 4, and then I have to calculate output at 5, and then I have to calculate output at 6. How do you calculate output at 4? How do you calculate output at 4? It's all about the summation of your inputs and weights multiplication plus the bias weight. What is the bias weight of 4? The bias weight of 4 is what? Minus 0.4. Right? Plus. See, you could see that. Minus 0.4. See, these 4, 5, 6 are the, 4 is the hidden layer neuron. 5 is also hidden layer neuron. 6 is your output layer neuron. But anyhow, in these units, I'm calculating output. So what is the value of 4, output 4? So it's all about x1 into, which and all the things are going to 4? X1 into W14, then X2 into W24, plus X3 into W34, plus the bias weight of 4 is W04. I have to add the bias weight always, right? Are you understanding? Yes. Who is the line? Yes, Kshitij.
Yes, ma'am. Sir.
If you have any doubts, please let me know. Okay. So x1 W14 plus x2 W24 plus x3 W34 into, plus the bias weight. So this is going to be 0 because the input itself is 0. So only two things will come, x1 and then x3 plus your bias weight of 4. That is what I have calculated it here. What is my x1 is 1 into W14, right? What is W14? 0.2. Yes. Plus, what is my x2? I think it will be totally 0. x3 into W34 is minus 0.5. So that is what your minus 0.5. And you are calculating output at 4. Since because you are calculating output at 4, you have to add the bias weight of 4, that is called W04. That is your minus 0.4. So the total value is minus 0.7. You have and you have to apply the activation function over minus 0.7. I told you already, activation function on the network output is 1 by 1 plus e power that output. So I will get 0.332. So what is the output you have calculated at 4 is this. So the value is 0.332. The value of this is, why I am writing it here, it will act as input to 6. The next one, the same way, the bias weight I have calculated at 5 is 0.525, because again same, x1 into W15 plus x2 into W25 plus x3 into W35 plus the bias weight is 0.2. So you will get 0.1, apply the activation function on that, you will get 0.525. The value here is, so you need to write once you wrote the figure, 0.525 0.525 value. So I think now this fellow will act as the input to go to 6. So bias weight of 6, what is that? W06 plus multiply the value of 0.332. This is the input into its weight. 0.332 into W46 value plus 0.525 into W56 value plus the bias weight. That will be the output at 6. You could see that the weight W46, I think I'm going from 4 to 6. W46 or W56. W46 is minus 0.3 into the output at 4 will act as input to 6, and then W56 into the respective output at 5 will act as input to 6, and then its bias weight, that is here W06 value. So I got this much. After applying my activation function, I got this much, 0.474. Let me copy that value also here. What is the value here? 0.474. 0.474. So this is the actual output value. Now, what I did is, I have traveled from 1 to 4 and then 6. So from my input network, I have traveled to hidden and then I have traveled to output. As per the algorithm, while I am going forward to the network, what I did, I have to compute the output of every unit in the network, right? I have calculated the output of unit 4, I have calculated output of unit 5, and I have calculated output of unit 6. When I'm going forward, when I'm propagating forward, I have calculated output at every unit which I am crossing over through hidden and then output. That I have done. Now I have to come back, since my outputs are not the stabilized outputs. You could observe 0.332, 0.525, 0.474. So till my outputs are going to be stabilized, means to either 1 or minus 1, what I have to do is I have to back propagate. While back propagating, my journey starts from the output. Now I am here. Now I am at 6. When I am back propagating, I have to calculate error at 6. So error at output is indicated as what? Del K. Here K is the output unit. Error at output I have to calculate. Error at hidden, I think I have to calculate two errors, one at 4, one at 5, because both are hidden layer network, hidden layer units. So I have to calculate del H. There are two separate formulas. So 1 del K, 2 del H. I have to calculate with the error. Again, I will update all these weights. What are the weights I have to update? W14, W15, W24, 25, 34, 35. So the error which you are calculating when you are propagating back will be helpful for you to calculate the updated weights, and then you apply again. Right? Till you get the outputs nearly equivalent to the maximum accuracy. Understanding? Yes, I need the answers.
Yes, ma'am.
What, others don't have any mouth to say the answer except Kshitij? Now forward propagation is over. I have calculated outputs at 4, 5, 6. Right? Now I need to back propagate. While back propagating, what I have to do, I need to calculate the errors at each node. So since I am at 6 right now, first I have to calculate error at output. Then I can go for calculating error at my hidden layer networks, that is 5 and then 4. Since I have only one hidden layer, I think you don't need to bother much. How many hidden layer units are there? That much you have to sum it. So let me explain you how you calculate errors when you back propagate, right? So this is the error term. Del k is nothing but the error at output. Anyhow, you are there in the output first. So actual output, OK, into 1 minus output. This OK is what? The output that you have calculated at 6, right? Anyhow, we know that 0.474 is the output which I have calculated at 6. 1 minus that and target output. I told you already. It is given in the question where T, target class value is 1. So I think this is same for the entire problem. So T value is 1. So no need to worry about that. Tk value is 1 minus the same output which I have calculated at 6. So OK into 1 minus OK, Tk minus OK, right? So that is output into 1 minus that output, then target class minus the output. So let me go there. What is the output you have calculated at 6? Is 0.474. You could see that. So OK into 1 minus OK into Tk minus OK. What is Tk did I told? Target class is 1. It is given in the question actually. Class, target class label. Class label value is 1. Fine. So if I did that, what is the value I'm getting is, this is my del k value. So what is your del k? Nothing but del 6. Del 6 equal to 0.1311. Right? Remember this. I think it will be useful for you. The next one is, what we have to do? We have to calculate the output at hidden layer. See, remember, output layer error calculation formula is different. Whereas whenever you are calculating the error at hidden layers, its formula is different. Since we have only one hidden layer, we don't need to bother much. Suppose if you have two hidden layer, this multiplication values is that no, this you have to summate with each layer. So what is the hidden layer error calculation? OH into 1 minus OH. So to which hidden layer you are calculating error? I think 4 and then 5 are the net units which you have at the hidden layer. Whenever you are calculating error at 4, you need to know about the output at 4 multiplied with 1 minus that output, and then what is the weight you are supplying from your, what is K? What is K? This is the label for output unit. Here K is, I told you, it is 6. H is 4. Right? Hidden layer is 4. Since I am calculating output at 4, my H is 4. My output is what? 6. That is here K belongs to your outputs. You could see that. H belongs to hidden. Whenever I am calculating the output, error at hidden layer 4, so H represents 4. The output is 6 here, that is called K. So the weight that corresponds to KH is what? Though it is WKH, because you are traveling from 6 to 4. What is the weight supplied between 6 to 4 is W, not 6, 4, it is W, 4, 6. Both are same. W46. And then what is del K? Del K is nothing but the error which you have calculated at your output just before. Right? The same formula, output into 1 minus output. What is the output you have calculated at 4? 0.332 into 1 minus 0.332. You could see that. What is the output I have calculated there? 0.332 into 1 minus 0.332. What is these two values? Is nothing but output at the, what is this? Del K into, I think error, del K into WKH. Right? No? WKH into del K. What is del K? Del is the error, right? Error at output. What is the error at output? Just now we have calculated 0.1311. So I have multiplied that. And then what is WKH? Since I am between 4 and 6, it is W46. What is a W46? It is minus 0.3. Minus 0.3. That is what I have multiplied. And this is the value I got. What is this? This is your del 4. This is your del 6. And then how do you calculate error at 5? Very simple. Error at 5 is nothing but what is the output at 5 into 1 minus that output. And then the weight between 5 and 6 is minus 0.2. And then the error at output, that is 0.311 del K. So you got these and all the values of errors. So remember, when I am forward propagating, what I have to do, I have to calculate the outputs at each unit. For example, how many units are there in hidden? That many units outputs I have to calculate at hidden. And then output I have to calculate at output layer also. When I am back propagating, calculate the error at output unit and then come to hidden layer. How many units are there? Please calculate the error at all the hidden layer based on the formula given. Remember, you would have two different formulas for calculating error at hidden as well at the output. So this is the formula for calculating error at output. So this is the formula to calculate error at hidden. Fine. Then, now we know the del K, del H values. We can easily calculate the updated weights. Your updated weight is nothing but the same weight plus the change in weight, little change in weight. How do you calculate that little change in weight is learning rate. It is given initially in the form, I think, question. Learning rate is 0.9. That is constant to the entire problem. And then del J means because you are back propagating, no? I think from 6 to 4 or 5 you had come. Now which of the weights you can able to change? First, because this weight updation also happening when I'm back propagating. The moment I calculated error here, the weight will be updated. So the moment I calculated error at 6 and error at 4, the W46 weight will be updated. Since I'm going from 6 to 4, I think it is written WJI. It is written WJI. But actually, in terminology, it is Wij. It is Wij given. Right? Fine. So now first you have to update W46, then W56, then 1415, 24, 25, 34, 35. Those are the weight updations. So what is the formula given to the weight updation is learning rate into whichever the del you are at. Suppose if you are at the output layer, calculate that you know the del and then the respective input. So the respective input here is what? This is the respective input now, because This value is output value. When I'm here to update W46, what is the input here? 0.332. X is the input, no? When I am updating W56, your input is 0.525. Okay. Let's go to the last one. So let me find out the formula first. I think if I write it over there, it will be easy. Learning rate into del J xji. So what is your weight updation formula? W is equal to the same weight plus del Wj. The del Wj, I will directly write it here. It is nothing but eta into del J into x ji. Why ji here is because we are back propagating. So instead of xij, they have given ji. I think it is same. Okay, W46. How do you update W46 is nothing but write the W46 as such. What is the W46 value earlier? I think it is minus 0.3. Write it as such, the same weight plus your learning rate eta is 0.9. And what is this del J? So error at 4.6. Since you are propagating from 6 to 4, right? I think you are at the 0.1311 because you are at error at the output you take first. 0.1311. And then what is this xij? It's nothing but the input, right? Input between whom? Input between 4 and 6. The input between 4 and 6 is what? That's why I told you to write it here. Between 4 and 6, the input supplied is the output calculated at 4. That is 0.332. Write down that. So you will get this much. Earlier the weight you see minus 0.3, right? Now the weight got reduced, actually increased, sorry, minus 0.2. Since it's negative, no, minus 0.3, it is minus 0.2. When you see all the overall, the weight is getting increased to attain the value called 1 or minus 1 overall output, because we got the output very less. That is, I think, somewhere 0. Output we have calculated here is 0.474. What is next? 5, 6. The same. The weight, same weight, W56 value which is given in the question, plus learning rate is 0.9, right? What is this value? The output, error at output layer. Which weight you are calculating? W56, right? What is J over there? 6. Wij, J is 6. If J is 6, del J is the error at 6. The error at 6 which we have calculated, and then the input we are supplying between 5 and 6 is nothing but the output we have calculated at 5. So like that we used to do for respective weights. W14 is also same W14 plus learning rate into what is the output we have calculated, what is the error that we have calculated for? Del J, right? Del is what? Error. Error at 4. J is 4 here. What is error at 4? You can see error at 4 is 0.0087. 0087. And what is this? Between 1, 4, right? What is the input we are giving between 1, 4? Input we are giving in between 1, 4. I think we are giving 1. So that is the input over there. So like that, all they have calculated. Any doubts? Once I think you need to solve this problem.